a concert tonight of a band I quite like. None of you have heard of them, so it does not matter. But they're a very good band, good Canadian kids from Hamilton. And their opening act is Frank Turner, who is also a wonderful English musician, who you also might recognize a song or two of his, but you won't recognize his name. Same with the other group. You won't recognize them. It's the Arkells. None of you know who they are. That's okay. But their music is very good. You might recognize a song or two. They are played on radio, but most of you don't listen to the radio anymore. You might be familiar with their most recent song, Private School. No? Oh, well, worth a shot. I'm going to that show tonight, and I'm taking the whole family, so I'm in a very good mood. My kids really like the live music, and it's funny when I take them to concerts, because there's not a lot of kids at concerts, because my kids are little. My daughter is already planning her outfit. She has her makeup out, and she has chosen her particular clothes that she will be wearing, because, you know, when you're going to a concert, it's a night out. You have to plan for these things. My son, of course, is like, I wonder what sweatpants I will wear tonight. But my daughter cares. It's very funny. She came in to the house yesterday and said, Dad, don't move anything in the bathroom. Why, Beth? Because that's all the makeup I need for tomorrow's concert. So, I'm very happy. I'm in a very good mood. So don't ruin it. Deal? Okay. So you guys already could fill this in without me, I am sure. But we are going to remind you of it. Multiplying powers of the same base. So we are in our purple book. Hello. Where'd I put my attendance? Attendance. 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 That. Yeah. Anywhere you want. Any desk you want. Do you have one of the books, yeah? Yeah, I gave it out yesterday. Okay, everyone does have a book, right? People in my other class don't have books. I don't know how. I made 30 books. You can't have more than 30 kids in a class. Yet there are kids in my other class like, we don't have a book. I don't know how it happened. You all have books, yeah? 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 Yeah. Okay. So multiplying powers of the same base. Now, guys, before I go too much further, I would like to remind you of a couple of things. Make sure we're on the same page. What's the base there? X. And only X. Okay? Right? What's the base there? 4x, which means what is being squared? The 4 and the x. Okay? It's a gross mistake, and I don't mean gross like really, really bad. I mean, it's a mistake that almost everybody makes, especially if I stretch this out with more variables. Okay? If I do something like this, 4xyz squared, a great many of you forget that the 4 is squared as well. Okay? Just remember that. So when I'm talking about base here, remember, it's everything that may or may not be a base. Cool? All right. But we'll start, as always, with easy ones. Multiplying powers of the same base. So the same base means just that. So again, you already know this, and you know that you have to add those. But just for teaching purposes, I like to remind you that this means x times x times x times x times x times x times x, which gets you x to the 7th. And the rule is, of course, x to the a times x to the b is x to the a plus b. Now listen to me. That word right there, even though it's hard to read because it's in a bad font, I don't think it's in a bad font on your guys' book, but it's in a bad font on here, says laws. What does the word law mean? It's a rule that is applicable when? Always. Okay? If I were not stunningly gorgeous and incredibly funny, would I still not be allowed to murder somebody? Yes. Okay? Because not murdering people, there's a law about it. So even if I didn't look this beautiful, I still couldn't murder people. Sadly, in North America, being rich and beautiful often allows you to murder people and get away with it, but that's not the point. In reality, of course, there's a law against it. This law applies always, no matter what the exponents look like. Okay? I get it doesn't look the same. I can't possibly do that. You do. It's a law. Everybody with me? All right. Dividing, same thing. Oh, I'm in highlighter mode, though. What an idiot. X to the 5 over x to the 3. Again, I like to remind you that's that many x's over that many x's. And then, of course, you cancel, leaving yourself with x squared. And the rule, again, is x to the a divided by x to the b is x to the a minus b. Again, no matter what. It doesn't matter what it looks like. You follow those rules. You know all of these, so it's not a big deal. That's why I'm going very quickly. This isn't news to any of you. You knew those two in the 9th grade, except you didn't use letters. You just used numbers. In the 10th grade, we added letters. In the 11th grade, we're going to, again, add something else, but it's still going to follow the same rules. An exponent to an exponent. Now, guys, is it all right that I stop with the examples? Can I go straight to this form? That's cool. Everyone's comfortable with exponents. So that is x to the a all to the b, which is x to the a times b. Now, there's, again, a rule here. We have to remember that b applies to the entire base. And that's the mistake kids make a lot with this. They forget that if that base is 10 terms long, all 10 of those terms get the exponent b. Okay? Everybody with me? Fraction base. X over y to the a. That's x to the a over y to the a. Now, the mistake that kids make here is they think that this is a situation where they can subtract the exponents, but it's not, is it? Why? Because those are different bases. Okay? This is not Law 2. Jordan, you made it. Cool in the gang. Have a seat. We've only done 4 things, and it's all stuff you already know. Oh, but you're cold. Yeah. You're giving off cold. I know, because it's cold outside. I had to go out and I had to warm up the car today. It's frightening. My dog's being stupid, too. He goes outside, gets cold, comes back in, sits on my lap, gets me cold. 2 seconds later, goes over to the door. Put him out. 2 seconds later. Stupid dog. He's got fur, so now I'm just leaving him out there. Then everybody in the house, oh, you're so mean, Dad. Why are you doing that? Ah. Are you going to get off your ass and let Cooper out? Oh.
That's what my dog's name is.
Oh, really? Yeah. They tried to name him Copper, but I was like, no. Animals get people names. So I went with Cooper. He's a good-looking dog. Huh?
What kind of dog is it?
It's this dog, Bryce. Right there. Oh, you can't see.
Oh,
He's
no, I can't.
Lab Shepherd. I was recently walking Cooper down the street, and there was a family behind me. And I was walking Cooper, minding my own business, and the kid behind me was acting like a feral child. Like, if he was my kid, there would have been serious repercussions for the way this kid was behaving. But he wasn't my kid, and he's being raised by somebody in our world today that believes kids are apparently sacred and can do anything they want without any repercussions. And he was going ape poo, and his mother kept yelling at him. and the kid's name was Cooper. So the mother is like, Cooper! Cooper! And my poor dog is like walking along, go, Cooper! Look at me. It's okay, boy, walking along. Cooper! Then he got all sad and put his tail down. It's like, boy, it's not you. It's okay. Anyway, another story for another day. Ah! See what I mean? That's my new computer. See how well it works?
We'll wait.
We will. That's interesting.
That's all you really need.
There we go. All right. An exponent of 0. This causes much grief as well. Everybody knows this one. Okay? X to the 0 equals what? 1. There's a lot of reasons for this. I can show you all the reasons you want. But first, I want to... actually, I'm going to show you those reasons. Why is that? X squared divided by x squared. What do you do with those exponents? You subtract, right? 2 minus 2, right? So that gets me x to the 0. But you guys know from all math, anytime you have the same numerator and denominator, what does it equal? 1. So that's one reason. Okay. The other reason is this. 2 squared equals 4. 2 to the 1 equals 2. So 2 to the 0 must equal 1 because you're dividing by 2 each time. Everybody's cool with that, right? Everybody has no problem with everything to the 0 equaling 1 until they forget previous exponent rules, which is what I talked about at the very beginning with bases. What is this value? 1. What is this value? Negative 1. What is this value?
1.
Positive 1. Okay. Bases are important. It makes a big difference. Most of you know, well, all of you know that somewhere in your brain already, but some of you forgot it. Okay, everybody is good with zeros? Everyone is good up to number 5? Those are the easy ones. Okay. Number 6. I want to come back to number 6 because number 7 is an easy one too. Not AB. I've been using X and Y. XY to the M is X to the M, Y to the M, which again you already know. Now negatives I'm going to take a moment with because again you all know something about it. You all know what it means, but there are subtle problems with it that sometimes mess you guys up. So we'll start with the easiest one. X to the negative A is really 1 over X to the positive A. Because what does X to the exponent mean? I take X and I multiply it that many times, yes? But this makes no sense. You cannot take X, repeat it by itself negatively. Right? It makes no sense. So negative exponents cannot exist. So the reason we do this is simply this. X to the 3 over X to the 5 is X, naughty, over X, 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 X. These X's all cancel, which again you already know, leaving you with an X squared in a denominator. Can I have 0 up there? No, of course I can't, because if I have 0 in the numerator, what do I have? 0. And this is not 0. Plainly, X has been squared, hasn't it? So this has to be a 1. That is why that works. Now, that seems easy, and it seems like not a problem. And everybody's like, yeah, okay, if there's a negative, it goes to the denominator. But there are situations that screw you guys up. For example, what is this? What's not allowed there? A negative 2. But it's already in the denominator. So where does it move? Back to the numerator. So that becomes 3x squared. Everybody cool? Okay. Now what about this? 3 over 4 to the negative 2. What do I do with that? I flip the 3 and the 4, don't I? Why? It has to do with law 4. Yeah, if I apply law 4, I get 3 to the negative 2 over 4 to the negative 2, don't I? And negative exponents aren't allowed, so the 4 in the denominator has to go up, and the 3 has to go down. Cool? Kelvin? Okay. Those are my favorite questions. When halfway through you realize you know the answer, and I get to sound smart, or feel smart. My son bought me this coffee cup for Christmas. It keeps my coffee too hot. I poured this at 7 a.m., and I'm still too wussy to drink it. My wife got mad at me today because she made me a smoothie for breakfast, but she makes her smoothies too cold.
You've got a lot of first world problems.
I know, right? I just read an article on that last night, Bryce, saying that calling other people's problems first world problems is the first world problem for bullying now. Because nobody really bullies anybody anymore, not the way it was back in the day, right? When bullying was, you bitch. Like, that was bullying. Ow, it hurts, right? Now, that person's stupid on Instagram. Whatever, that's fine. But you shouldn't belittle other people's problems was the point of the argument. Because they recognize, I know that that's a first world problem, but it's still an annoyance, right? I mean, really, a mosquito buzzing around your ear in the middle of Africa is really an annoyance, isn't it? Except it's carrying malaria. So you go like this, no big deal, and it's gone. Unless it bites you and then you get malaria and die. So that little problem of a mosquito is actually a problem that needs to be worried about. You understand what I'm saying?
I don't know if that analogy applies to hot coffee, but...
I disagree completely. Anyways, my wife was mad at me. She's like, I can't make the coffee. It's too hot. I can't make the smoothies. It's too cold. She puts ice cubes in her smoothies. No! It's water. It melts and makes it thin.
Because the ice cubes are solid and it's just like frozen fruit.
Yes, you put frozen fruit in, not ice cubes. The frozen fruit makes it thick, not the ice cubes. It was hurting my whole esophagus. And then the coffee was too hot to warm it up. Shut up, Kelvin. You guys are hurtful. I like you guys. All right, so we're all good with our review, yeah? Okay, this page I want to do as notes because there's some new stuff on here. The next page in your book you're going to do on your own, right? But there's no answers for it. You're going to do on your own kind of, and I'll put the answers up. I'll let you try, then I'll put the answer up. And then the couple of pages after that is work for you guys to do with answers in it. Okay, kind of like textbook work. Everybody good? All right, so let's go with this. The key here is positive exponents. You are never allowed to hand something in any discipline that deals with numbers with a negative exponent because they don't exist. Okay? Everybody cool? We change every exponent. So we'll start with this one. It's got no letters, so it's pretty easy. Which laws apply? You know which laws apply. That's going to apply to law 4, right? Because it's going to apply to everything. So remember, the law applies regardless of what the question looks like, right? So if I were to fill this out and actually show all my work, I would write 3 to the negative 2 times negative 3 over 4 to the negative 1 times negative 3. And I would get 3 to the 6th and 4 to the 3rd. Right? Is everything positive? Am I happy? Yes. Could you take this one step further? You could evaluate it, couldn't you? You could tell me what 3 to the 6th is. It's a big number. It's 729, I think, over 64. This is 3 to the 6, 729. Thanks, buddy. Okay. I don't want that. All right? Unless it says to evaluate, I want you to leave it as exponents. All right? Everybody cool? When it looks like this. As always, there's exceptions to that rule. We'll get to them when we get to them. Okay? This one, same thing. It applies at law 7, because I got, or law 1, because I got multiplying here. Law 7, because I've got to come in through the, from the outside. And I got law 3. Where do you start? Where do you start with this? Because you don't have to start where I would start with it. Where would you start, Michaela? What would you do? There's no wrong answer.
I would do 4 to the 5, and then add that.
Sure. Yeah, absolutely. That's fine. There's brackets there. Go ahead and do that, right? That's okay. Could you also apply this law? And then do the adding that Michaela said. Does it matter which way you do that? No, it doesn't. That's the concern I have with this. Because sometimes if you guys aren't so hot at math, you ask me or a friend, how do I do this? And if they show you a method that you still don't get, you're still screwed. Do you understand what I'm saying? You got to know what you're doing, not how to do it. Kelvin. You could, that's what I'm saying. In exponents, that's the way you want to go because you know BEDMAS, right? But you will find that both work. And understanding math allows you to apply them in the right situation. Because there's sometimes when you have brackets that you don't want to do inside the brackets first because it makes it more complicated later on. You know what I'm saying? That's why I'm trying to say there's no right way to attack this as long as you apply all the laws. Okay? And here's what I mean. Michaela wants to do the brackets first. That's cool. If she did and you did, go ahead. But watch what happens. If you do the brackets first, you get 5 minus 2, which is 3, right? Right? And 3 squared becomes 6, yeah? So I would have 4 to the 6th in the numerator. Agreed? Now if you go this way, 4 to the 10th, right? And 2 to the negative 2 is 4 to the negative 4, yeah? 10 minus 4 is still 4 to the 6. You see what I'm saying? And in this case, it's easy to see that. But in other cases, you might want to get rid of that exponent out there first. And I'm just trying to say you're allowed to. So I got that over 4 to the 4th, right? Which gets me 4 to the 6th over 4 to the 4th. Then I subtract 4 squared. Everybody good? And of course, I could go one step further there and make it what? 16. Everybody okay? Everybody remembers how to do this, yes? Please be aware, I recognize how easily we are starting here. I know that I said on the first day that pre-calc 11 is hard. It's only hard if you're not good at this stuff. Do you understand what I'm saying? This easy stuff, if you get it, then you're going to be fine. But if this stuff is like, oh, I don't quite remember that, you got to make sure you know it. Oh, that one says evaluate. Thank you, Kelvin. 16. That did say evaluate, so we would carry on. Thanks. Okay, the next one says evaluate again. So we're going to work it out and then evaluate it. We can do the same thing as before. So I'm going to use Michaela's method this time. So that's 3 to the 3rd to the 4th over 3 to the 10th, which is 3 to the 12th, over 3 to the 10th, which is 3 squared, which is 9. Everyone's cool, yes? What's different in number 4? I have variables. So can I evaluate it, Joel? No, because I don't know what x is. X to the negative 10 over x to the negative 13. What's the answer? Kelvin? 1 over x to the 3 is your guess? Okay. Anybody want to contradict that, Lucas? It's x cubed. Why, Lucas? Because you did the right thing. You knew it was 10 and 13. But you can think of it two ways. One, they're both negative, so they both move, right, Kelvin? Or, isn't that negative 10 minus negative 13? And what do two negatives get me? Cool? That's the type of thing that you guys know that's easy, but it's just as easy to screw up, isn't it? Right? If you rush this, negative 10 minus 13, that's what you did, right? Or no, you did 13 minus, I don't know. But you know what I mean, right? Usually at least one person in the class tells me it's x to the negative 23, which is 1 over x to the 23rd, because they do negative 10 minus 13, right? Everybody's good? Okay, do the next one. Because now we have numbers and letters. So again, this is a situation where the method you use can make it easier or not. If you get locked into, I have to do this, then this, then this, then this, then this, then this question becomes a little bit difficult. Because some kids always do this. Okay, Myers says that 2 applies to everything inside, so that's 4 to the negative 2 and x to the negative 4. I don't like doing that. Why? You can miss a step, right? But if you really understand your math, what do you get to do with that negative 2 with everything in here? Sid said it earlier. I can flip the whole thing, can't I? Now again, if you're only paying attention to what I'm doing, you can make errors. When I flip it, what's the only thing that changes? Just the exponent. Nothing in the base. Okay? So if I do that, I'm going to end up with 2y cubed over 4x squared, all to what power? Positive 2. Now I can get in there and fix it up. Everybody with me? So where would you go now? Where would you go, Kelvin? Sure. Why don't they change? Because the only part of the reciprocation that you're fixing is this square. And I'll show you what I mean. If I had x to the negative 2 over y to the 3, right? That is really 1 over x squared y cubed, correct? Cool? Okay. But if I did this, now my eraser's not working, whatever. I'd like everybody to recognize how calmly I'm accepting this today. No, my day is still good. Going to a concert tonight, taking the whole family. It's going to be fun. Don't know what that black box down there is. Now, Kelvin, if I put a negative 2 out here, okay, if I just follow the laws, that gets me x to the positive 4 over y to the negative 6, correct? Which gets me x to the 4th over y to the 6. You with me? Now, if I flip this, I'm going to get y to the 3 over x to the... Now, you're saying that negative 2 should change, right? Because I flipped it. Cool? And then I change this, yes? Go from negative to positive. You with me still? Now, if I apply the law, I get y to the 6th over x to the 4th. And we know that's wrong, don't we? It's just from following the laws that we find out that you can't change the internal exponents. Because then you're flipping them technically twice, aren't you? And you don't want to do that. You with me? Sorry about the sidebar there, guys. Anyways, I don't know what that black box is doing there. I'm hoping it will go away. There we go. It's Cortana. I know, right? Okay, so I would tidy up inside the brackets first. Now, this is an example of what I was talking about earlier. All of you know that it's y cubed, but what's the coefficient? 2 cubed, which is 2 cubed is 4?
Oh, cubed. 4 times 2, 8.
8. So this is 8y cubed over 4x squared, and that whole thing is squared. So what is getting squared? Everything. 8 is getting squared to become what? Y cubed becomes y to the 6th. 4 squared is 16. X to the 4th. Would I leave it like that? No. Why? Because Mrs. Bad Crumble doesn't like it when you don't simplify your fractions. 64 over 16 is 4. Y to the 6th. X to the 4th. That's about a grade 10 question. That's about where your grade 10 exponent lessons ended. Is everybody good? Now, obviously, you haven't thought about exponents since the 10th grade when you did this, but now that you've seen it, we're all on the same page now, right? Okay. Now, if you look down the next column on the right-hand side, you'll see that I start messing with some of these things, right? The exponents look different. Does that mean we treat them differently? No, it does not. So let's have a look at them. Again, I want to use these kind of as notes. So this one, what do you notice about this expression? The exponent has a variable. What do you notice about the bases? They're the same, and I'm multiplying, yeah, or dividing, yes? Do I have an exponent law that covers that situation? I do. What does the exponent law say I do with the exponents in this situation? Subtract. So this becomes 8, and the exponent becomes 12x minus what? Negative 2x. So what does it really become? 8 to the what? 14x. Everybody cool? It looks weird. The rules apply. Now, some of you should be saying, well, how can I have an x in the exponent? Don't worry about that. That's not the point of this. The point is to show you that that can exist. In Pre-Calc 12, you'll learn what to do with that. Okay? But right now, the point I'm trying to make is even though it looks funky, we follow the same exponent rules. Now, Joe. Okay, again, we come to this situation. X to the 3rd over x squared, or x to the 13th over x squared. That's just x to the 11th, right? Same thing here. The base doesn't change. Here's why. 8 squared times 8 squared. It's not 64 to the 4th, is it? Right? Because this is really whatever 12x is. Say x is 1. This is really 12 eighths over 2 eighths, right? Cool? Okay. So what do I do here? Same rules apply. What are you going to do with the 20 and the 5? I like to do these separately. Numbers with numbers, letters with letters. So what I have here is 20 over negative 5 times x to the negative 20 over x to the negative 5. Well, what's 20 divided by negative 5? Negative 4. And what do I do with these exponents? Subtract them. So what's negative 20 minus negative 5? Negative 15. Now, what if you leave it that way? Is it right? Why not? What's wrong with that? A negative exponent. So what has to happen? What flips, Jessica? The x, the 4, or both? Just the x, because the x is the only thing that's a base here. Does everybody understand? So this becomes negative 4 x to the 15th. Everybody cool? Okay, you guys try number 8. You're probably going to get it wrong, some of you. There's a really tricky thing at the end of it that I'll be interested if people catch it. Remember, all the math that you know applies all the time. You might have learned something in the 6th, 7th, 8th grade that you need here. So, you've had a bit of time to look at it. Some people I heard, Michaela, the first thing you said 5 seconds in, I'm already stuck. Right? So, I'm assuming some other people are too. That's why I'm saying you've had a bit of time to look at it. There's probably a couple of people like, I'm not sure what to do here. What are some options?
You could try to separate it. But...
I've already separated it to deal with the numbers, right? That we can cover. What's weird in my exponents here?
Your exponents is times by something else.
Yeah, the exponents are a mess, aren't they? Now, if this was the 9th grade and I gave you this question, 16n minus 3, what would you do? You would distribute, wouldn't you?
I think you mean flying arrows.
I think I do flying arrows. I would distribute that, yes? So what do you think we do here? Distribute it. So I'm going to get x to the negative 32n plus 48. Everyone agree? Everyone okay with that? Okay, what is my denominator? Minus 4. Everyone agree? Okay. Do I have the same base? Is this division? Do we have a law for that? The law says what? Subtract. So what I need to do is this. I had negative 32n minus 48, yes? Plus 48 it was? Thank you. And I am subtracting 4n minus 4, right? 4n minus 4. Well, what's negative 32n minus 4n? Negative 36n, correct? And what's 48 minus minus 4?
52.
Plus 52. That's from grade 9, right? So now bring that into grade 11. So this becomes x to the negative 36n plus 52. Is everybody okay with that? What there is bothering you? That negative 36, correct? Because as soon as we see a negative exponent, we know that's not okay. right? But what's weird about this situation? It's not just negative 36, is it? There's a positive in it, isn't there? Somewhere in this expression, there's a negative number, yeah? Where is it? It's only at the beginning, right? So think back to the 10th grade. How do we get rid of that negative here? Divide by negative 1. I'm bringing it out, right? So if I divide this by negative 1, what do I get?
36.
Negative 36n, what? Minus 52. Now, do I have an entire negative exponent? And what do I do with entire negative exponents? You move it. Somewhere it's got to move, right? That's a tough question, yes? Because it looks weird. But we had all the math tools to deal with it, didn't we? So we're going to fix that up again, and it's going to become x to the negative 36n minus 52. Now I can fix it up. What goes in the numerator? Negative 4. Because he's got no negative exponent, right? My variable goes to the denominator and becomes what? Yeah. $36n plus minus 52 still. Because we changed the exponent. If it was just an x, if it was x to the negative 4, when it went down there, it would be x to the positive 4, wouldn't it? The 4 doesn't change, just the sign in front of it does. Cool? Right? It's nothing new, but it's 7 steps together. Now you got to think back. Well, wait a minute. We learned distribution in grade 8. We learned exponents in grade 9. We learned factoring in grade 10. So you got to put all those things together, right? Everybody good? All right. I heard an Was that Jessica?
Yeah.
Okay, hit me.
What did you do with the 16?
Oh, I just divided them. 16 divided by negative 4 is negative 4.
Okay.
Cool? Okay. Jessica, do not feel odd asking those questions. When a bunch of crazy stuff happens, people are always like, what happened over here? Because I don't get it. But you do. Sid.
Isn't there still a negative exponent then?
No. Because this is one thing. If you know what n is, that's one thing. Might it be negative? Yes, but we don't know. So we got to leave it. Now, does this apply much even in pre-calc 11? No. That's like the extent of where we go with our exponent laws. Now I got some nice easy ones for you though. Why are they easy? Because you're just following basic laws. But again, there's more than one way you could do it. Right? How many of you with number 9 want to do inside the brackets first? Michaela, I know, does. So let's see if it's okay. Oh, the brackets have 3 different things. What should I do in there? I should split them up. I have 6 over 2. I have x to the 3 over x. And I have y over y to the 4th. Correct? What is 6 over 2? 3. X to the 3 over x. X squared. And y over y to the 4th. Y to the negative 3. Now, as soon as you see y to the negative 3, what do you want to do? Move it somewhere, right? I don't recommend doing that. Why? If you do this method this way, what if that 2 was a negative? Then it might change everything inside, correct? So I don't move things until when? The end. So I'm going to have y to the negative 3, right? And all of that is what? What does that get me? 9, good. Nobody forgot that the 3 is part of the base. X, 4, Y, -6. Are we at the end now? We're at the end enough that we can move stuff around, right? 9x, 4, y, 6. Gouda? Great. Number 10. Yes.
What if you put the y6 on top of the 9x?
Okay. Number 10. The whole thing isn't in a bracket, so can you do anything up and down first? No. We got to deal with the numerator and the denominator separately. What's the numerator? -2 ab squared all to the 4th, right? What is -2 to the 4th? (16). A to the... Nope. Negative times a negative is positive, times a negative is a negative, times another negative is a positive, right? What? How? This is -2 to the 4th power. Okay, so -2 times -2 times -2 times -2 is... Those are 3 words that I really want to ban being put together. I'm so confused. So, 16 what? A to the what? 4th, B to the 8 over. Now this is weird down here, isn't it? What's weird about it? The 2 distributes in. When?
After the exponent.
After the exponent distributes in. Why?
Bed mass.
Because of bed mass. So are we touching this 2 yet? No. What's my variables now? A6, B3. I don't need that first bracket now, do I? Okay. So now what? Now what should I do? I like to split it up. What's 16 over 2? 8. A to the what?
Negative.
-2. Are we good enough that I can just slide it down to the denominator now? Okay, A to the 2 and B to the... And it's positive, so it stays where? In the numerator. Cool in the gang? Okay, now, look at number 11. Which one's easy render? They are when you stop and think about it, right? They all follow the rules. You just have to stop and do each rule. Now look at 11. Yeah, what's ugly about 11? Everything about that is hideous, isn't it? It shouldn't be. 4, 8, 16. Barf, those aren't the same base, or are they? Are 4, 8, and 16 the same base? They're multiples of what now, Joe? Multiples of 4, but they're also multiples of 2. Can we do something with exponents and 2 to get us to 4, 8, and 16? What? What is 4 really? 2 squared to the x, yes? Times, what is 8 really? 2 cubed to the what? x plus 4 over, what's 16 really? 2 to the 4th to what power? X plus 1. Okay. Do I have an exponent law for going over brackets? What is it? Distribute. So it's 2 to the 2x, yes? Times 2 to what power? This is where someone's going to screw up. 3x plus? Oh, damn it. Actually not damn it. Good job. Over what? Four x plus 4. Now, is everything the same base? So what do? I just add it up, right? I add at the top. What's 2x plus 3x plus 12? 5x plus 12, yes? Over 2 to the 4x plus 4. What do I need to do with those exponents now? Subtract them, because it's division. What's 5x minus 4x? 1x. What's 12 minus 4? 8. Now, most of you were appalled by this, weren't you? Until this. And then all of a sudden, I have rules for everything. You're always allowed to do that. Math is good that way because 4 can be written in a million different ways, can't it? 2 times 2, 4 times 1, 5 minus 1, 1 plus 3. Those all equal 4, don't they? All right, so you guys, I'm going to ask you with each other for the rest of the day to finish, I believe it is page 6 in your books. Is it? Finish page 6. Your homework is the next couple of pages. If you turn to page 11 in your book, there are all the answers. Okay? The answers to page 7, 8, and 9. And 10. You're doing 6. No, 6 you're doing right now in class. I'm going to put the answers up at the end. Okay? I'm going to walk around and help people, then I'm going to put all the answers up at the end. Okay?
Why does this use both the variables v and u? That's kind of annoying.
I know, right? Because, Bryce, honestly, if I had a nickel for every time a kid said, I can't do this math because the letters are different, I would be rich. That's how many times have I said today, does it matter what it looks like? No, right? You've been in my class for 3 years in a row. Do I use X and Y all the time, or do I sometimes make my variables fish and lightning bolts?
Sure, you are a big fan of fish and
I
lightning
am.
bolts specifically.
Specifically fish and lightning bolts. And does it change how we do math?
No, I'm complaining more that v and u
I know.
tend to look similar.
I know, they look similar. And then I reversed them. I put V before U and U, right?
Oh, yeah, you did.
I know, right? Yes. Yes. That's times. Yeah, that's times. It just took me like 30 seconds to do -3 minus 6. I couldn't, I'm looking at it and I'm like, -3 minus 6, -3 minus 6. Huh? What? Huh? And now I got it. And now I realize I've written it down wrong. No, I wrote it down right. God. Jeez.
So that I can inevitably break it and I'll chart it properly again. You never had that though, where you like sharpen it once and then it breaks and then you can literally never sharpen it again. It's worthless. Gotta protect the orange one.
Wait, Jenny.
Yeah.
Yes.
Oh, the number 9. I don't know what I did wrong because, like, when I did it the first time, I got that as the answer.
Because you did 6 squared isn't 12.
Oh.
6 squared is 36. Remember?
Oh.
And it's 6 times 6.
Yeah. Okay.
That's probably why. I didn't look any further, but that's a pretty big mistake at the beginning. I'm just doing the last one on page 6 for you guys. Then I'll be around and start helping. Yes, Kelvin.
Is that like a minus or times?
That's times.